Good morning and welcome to the video for Friday, May the 15th for 6th grade. Today we're going to be looking at a new lesson that's going to continue this idea of working with measures of center and variability. And so the idea is we want to be able to talk about what these things mean in a way that we can explain the results of what we found to someone else. So since we're going to kind of look at how we would interpret the data, let's take a look at our unlock the problem. And so to save a lot of writing, I've chosen to make the baseball team red and the basketball team orange. My thought behind that is since baseballs typically have red seams and basketballs are typically orange, that would be easier than trying to write out something or abbreviating. So we have both of our medians. The median for basketball is going to be larger as in terms of height of the players compared to the median of the baseball team. However, the baseball team is going to have more variation in the heights of their players than the basketball team will. So let's go ahead and apply those things to our statements here. So the median of the basketball team players' heights is 8, so we can do 78 minus 8 to get that. 8 inches greater than the median of the baseball players' heights. The interquartile range of the baseball team, so again we're looking at this, is greater than the interquartile range of the baseball team. So the heights of the baseball players vary more than the heights of the basketball team. So the players on the basketball team are typically taller than the players on the baseball team, and the heights of the baseball team vary more than the heights of those on the basketball team. And so this is the big takeaway of what we can say that this data represents. And so as we move down the page a little bit, we have a follow-up question. So this is also an important thing that we need to look at when we're talking about statistics. So Julia randomly picks one player from a basketball team and one player from the baseball team. Given the data in the table, can you say that the basketball player will definitely be taller than the baseball player? So think about that for a couple moments. Pause the video if you need to while you think about that and write down your thoughts. And when you're ready, go ahead and hit play. All right, so assuming that you did that, one of the things that is dangerous with statistics is assuming that just because something can be true means that it always will be true. So even though our basketball team players on average are taller than the baseball team players, it is possible that a baseball team player could be taller than a basketball player or the same height as a basketball player. So the answer for this would be no for those reasons. All right, so let's take a look at number 2 at the bottom. Which measure of center would best describe Joey's data set and explain? And so we can work with all 3 of these options. Now, only one of them is going to be the best. So our mean actually works out really well. It would represent the average. And many of the data values are close to that. I would say that the 7 data values that I'm kind of circling around are all kind of within 1 or 2 points in terms of value from that. So that would be a really good measure. Our median might be better because we would end up with a value of 2 for that. And so now we're going to have 9 out of our 10 data points fall within 1 or 2 points of that. And so our 13 is kind of an outlier, so we're not going to really worry about that. Our third option would be modes, and we have 4 of them. And so while the modes might help represent that we have a lot of repeated values, as a measure of center, it's not going to be the best way to represent the data that we have. So I would argue our median would be the best because we can have 9 out of our 10 data points in close proximity to that. So let's go ahead and take a look at our share and show. So I've kind of pre-written some things. The main idea that we're going to be working with for number 1 is talking about what all of this means. So for number 2, I went ahead and given everything in order so that you can find the median as well as the range a little bit more easily. Keep in mind with these, since we have 7 data points, it's going to be whatever the center or 4th one is. for the median, and then the range is just a simple subtraction problem. So I'm going to go ahead and let you pause the video real quick to work on these two things, and then we will go ahead and talk about these. All right, so assuming that you did that, let's go ahead and take a look at number one. So player one's points for the mean is going to be less than player two. The interquartile range of player one is also less than the interquartile range of player two's points. And so player two typically scores more points than player one, but player two's scores vary more. So if you're looking at this from a kind of sports perspective, I would argue that player one is probably more consistent, but doesn't have as high of an output, especially on the top end, as player two could. But player two is really hit or miss. They'll have days that are really, really good, and they'll have days that are really, really bad. And so if I were a coach, I would probably want both of these players on my team given the average points scored, but I would have to understand that maybe if player two is having a cold game, that maybe we would have to make some changes. Or maybe that could be the reason why their range is so high. They have bad days and maybe the coach pulls them out. So let's go ahead and take a look at number two. And so what we're looking at is the median and range. And so for the median for A, we're looking at 7. For the median for B, we are looking at 11. Excuse me. And so with that, if we are going to compare the data, our average is going to be much greater for shelter B than it is for shelter A. Now let's take a look at our range. So our range for shelter A is going to be 15 minus 5, which is 10. Our other one is going to be 15 minus 4, which is 11. So what I am seeing is that both of these are really close together. And so I would say that there's a slight difference in the amount of variability, but on average, shelter B is going to average more than shelter A as far as the weight of their puppies. And so now let's take a look at 3, 4, and 5. So we're working with how to represent different facts about the data when we're given a table. And so this is about music, which I love. I'm a musician. I'm part-time for a very long time as a professional musician when I'm not teaching. And so this speaks to me a lot. But one of the things that I will say is if you start looking at the number of hours per week, it's like, some people might be like, wow, that's not very much, or wow, that's a lot. And so if you're always ever interested in participating in a sport or music or anything like that, don't feel like you have to limit your participation in that particular activity based on either how good you feel that you will be or are at that particular thing, or how much time you have to devote to it. Especially as you're going through school, explore all the different options you have available with sports, with clubs, with music, with drama, whatever you can be involved in that you can have a positive experience in, definitely pursue that. Which two students typically practice the same amount each week, but had about the same variation in practice time. So the variation, we are going to look at range, and we are also going to look at the mean for the first part. So if I look at the mean, I have a duplicate of 5 for both of these. I have a range of 2 and a range of 3. So they're very close. They're not identical in the variation, but they're close enough that we could say that we could pair those two together. And so we would say Sally and Jennifer would meet the requirements for what we're asking for in question 3. Number 4, which two students typically practice the same number of hours but had very different variations? And so we have 3 out of our 4 players that averaged 5 hours a week. And so we could say that the one that has the most variation of the people that practice 5 hours a week would be Tim. And then the best comparison for that, we would probably say Sally. We could also maybe include Jennifer with that. So, but since we're just doing 2, we want to pick the greatest variation. And so that would be Tim and Sally. Number 5, which 2 students had the same variation in practice times, but typically practiced a different number of hours each week? We would be looking at our range here for the starting point. And so our range of 12 would be identical, and both of these people have drastically different number of hours per week on average. And so that would mean Matthew and Tim would meet the requirements for that. All right, let's go ahead and take a look at our homework problems. For number 2, we're looking for any peaks in the data, and so you could say that there might be 1 or 2 of those. Describe any gaps. We would be looking for something that would have a frequency of 0. I don't see anything there for that. Does the graph have symmetry? We want to look at, can we draw a line down the middle of the graph and have a reflection or close enough to it on either side? The example I gave earlier where we might be able to argue, I don't think we would have as good of an argument for this one. For number 5, we are looking at our dot plot, and we want to go ahead and talk about the results. So we are going to be looking for peaks, we're going to be looking for gaps, and we are going to be looking for clusters when we talk about that particular thing. For number 6, describe how a graph can be used to understand the distribution of data. So you could kind of take a look at the same kind of questions we would answer to describe number 5. You could also talk about measures of center and variability with that. Number 1 on the back, all we need to do is look for the median age. So go ahead and put the numbers in order. Figure out where your center point is going to be as you calculate that. For number 2, we're looking for the median. What I would recommend is figure out the number of data points we have and start counting from the bottom. Once you get between the appropriate numbers, then that will tell you what your answer should be. For number 3, talk about where the gap is going to occur in the data. So it looks like we are going to have 2 different values, so you could list both of those values as the gap. For number 4, where does the peak occur? This is going to be a little bit different from our previous example on the most recent page, the one that I'm dragging over onto the screen right now. We would possibly say that we only have 1 peak for this because of the way this is scattered out. So that's why I didn't ask for potentially more than 1. This one we could maybe say that we have 2 of them. For number 5, we are looking for 2 teams that have a similar variation, so that would match the range, but have a drastically different number of points per game. And for number 6, I would recommend that you try working with the median as well as the mean and figure out which one would best represent the data. We don't have a mode for that. That concludes everything for our lesson for today. If you have any questions, please feel free to reach out in Google Classroom if you're one of my students, or reach out to your classroom teacher if you are not. Have a wonderful day. The homework video for this will be coming out on Tuesday, and then we will have our final lesson of the school year on Wednesday. Have a great day, and I will see you tomorrow.